Hello class, we're about to start section 10.2, triangles. Our objectives. We want to solve problems involving angle relationships in triangles. We want to solve problems involving similar triangles and solve problems using the Pythagorean theorem. Vocabulary and symbols. Closed geometric figures. If you start at any point and trace along the sides, you end up at the starting point. The triangles. A closed geometric figure that has three sides, all of which lie on a flat surface or plane, which is shown here. Euclid postulated that only one line could be drawn through a point not on a line that is parallel to the first line. If transversals are constructed through A and C and through B and C, triangle ABC will be formed. Now it says here angle 2 is equal to angle 5 and angle 1 is equal to angle 3. They are alternate interior angles. Angle 1 is equal to angle 3 and angle 2 is equal to angle 5. They are alternate interior angles. Angle 3 plus angle 4 plus angle 5 is 180 degrees. They combine to make a straight angle. Angle 1 plus angle 4 plus angle 2 is 180. Substitute angle 1 for angle 3 and angle 2 for angle 5. So, the sum of the measures of the angles in a triangle is 180 degrees. Euclid's theorem. Theorem, a conclusion that is proved to be true through deductive reasoning. Euclid's assumption. Given a line and a point not on the line, one and only one line can be drawn through the given point parallel to the given line. Now we have some parallel lines here. And then it says here, we have Euclid's theorem. The sum of the measures of the three angles of any triangle is 180. But before we get here, let's take a look here. We have parallel lines. And this is a line and this is a given line. And it says here that given a line and a point not on the line, one and only one line can be drawn through the given point parallel to the given line. So we could even make a point here. There's only one line that could be drawn that will connect these points here. Or we could have put a point here. It's only one line that will connect that. Now, the sum of the measures of the three angles of any triangle is 180 degrees. So proof, measure of angle 1 is equal to the measure of angle 2, and measure of angle 3 is equal to the measure of angle 4. Alternate interior angles. Angles 2, 5, and 4 form a straight angle, 180 degrees. The measure of angle 2 plus the measure of angle 5 plus the measure of angle 4 is 180 degrees. Because the measure of angle 1 is equal to the measure of angle 2, replace the measure of angle 2 with the measure of angle 1. Because the measure of angle 3 is equal to the measure of angle 4, replace the measure of angle 4 with the measure of angle 3. And when we replace this gives us all the angles we had in the triangle. 1, 5, and 3. And now we have 1, 5, and 3, and that equals 180. Now, example. The sum of the measures of the angles in a triangle is 180. Find x. So it is right here. We want x. So we look here. All three of these angles added together is supposed to equal 180. So we add x degrees plus 45 degrees plus 35 degrees is supposed to equal to 180 degrees. Now we combine like terms. We add x degrees plus 80 degrees is equal to 180 degrees. We subtract 80 degrees on both sides. And our final answer will give us x is equal to 100 degrees. So your x degrees is equal to 100 degrees. Now, it says here the sum of the measures of the angles in a triangle is 180. Find the measures of the numbered angles. Now if we look here, we have 25 degrees here, and we know this 25 degrees and this angle 6 here form a straight angle. So we know this will have to be 155. Because remember, a straight angle forms 180 degree is 180 degrees. Now if we look here at angle 6 and 4, they form a straight angle. 155 here, so then that means that angle 4 would be 25 degrees. Now I'm just going to write it over here to the side because I don't have enough room. So angle 4 is 25 degrees. Okay, now what we do next is this here. We take a look at, so we could take a look here at angle 1. If you look here at angle 1, you notice here that this angle is 90 degrees, and angle 1 and this angle here is supposed to form a straight angle, which is 180. So if this is 90, then that means angle 1 is also equal to 90 degrees. Now we have two angles of a triangle here. So we can add these two angles up to figure out what the third angle would be. 35 and 90 is 125. So we could take 180 minus 125, which would give us 55. So angle 2, and remember this is for lack of space, angle 2 is 55 degrees. Now if we look here, if angle 2 is 55 degrees, we know this blank space must be 125, because remember, the straight angle is equal to 180. So if angle 2 is 55, then this blank angle would be 125, which would make angle 3 55. Because angle 3 and this blank angle forms a straight angle as well. So that must equal 180. So now we have angle 4, which is 25, angle 3, which is 55. So that's a total of 80. So angle 5 must be 100. And these are all the angles for this triangle. So we scroll down here. It says find the measure of angle A for the triangle ABC. Now we have two of the angles here. Now remember, it still must equal 180. So we have 180 minus 120 and 17 is 137. So that will leave us 43. So angle A is equal to 43 degrees. Now, we go to our next example. It says find the measure of angles 1 through 5. Okay, so now this is what I'm going to try and do. I'm going to try and make this a little bigger so we can see it a little better. Okay, now right here we notice this is a 90-degree angle. We know this angle and angle 1 forms a straight angle, so angle 1 must also be 90 degrees. So we add angle 1, which is 90 degrees. Okay, so if angle 1 is 90 degrees, we know 90 plus 43 is 133. So we'll take 180 minus 133, which would give us 47. So angle 2 will have to be 47 degrees. Okay, so now we took care of that. Now what we have next is this here. We know that angles 2 and 3 are alternate interior angles, so that means they equal each other. So we have here angle 3 is equal to 47 degrees. Okay, so now we have angle 3. We can find angle 4 because we have angle 3 and it's 60 degrees. So we add two of the three angles. So we could take 180 minus 60 plus the 47 degrees will be 107. So 180 minus 107 would be 73. So angle 4 is 73 degrees. Now we can find angle 5 because angle 4 and 5 form a straight angle, and we know that they're supposed to equal 180. So we'll take 180 minus 73, and then that would give us 107. So angle 5 is 107 degrees. And these are all the angles for 1 through 5. Now we move to the next problem. It says one angle of a triangle is twice as large as another. The third angle is 20 more than that of the smallest angle. Find the measure of each angle. Okay, so it says one angle of a triangle is twice as large as another. the third angle is 20 more than that of the smallest angle. So we would have x is the smallest angle because all the rest are dependent on the smallest angle. And then the next angle is twice as large. 2x is another angle. I can't really tell if this is the largest or the middle, so we'll just put another angle. And then the third angle is 20 more than that of the smallest angle. So it'd be x plus 20 is equal to the final angle. Okay, so now we know adding all three of these angles together, x plus 2x plus x plus 20 is supposed to give us 180. So we combine these like terms. We have 4x plus 20 is equal to 180. We will subtract 20 on both sides, and we will have 4x is equal to 160. We divide each side by 4, and x is 40 degrees. So now we have the smallest angle is 40 degrees. So we have 40 degrees is the smallest angle. And then we could just say, maybe I should have put second angle instead of another angle and make this third angle. So this is smallest angle, second angle, third angle. Okay, so the second angle is double this, which will give us 80 degrees. Is the second angle. And finally, the last angle, we'll do 40 plus 20, which is 60. So it's the third angle. And this is 60 degrees. This is your final answer. When you add all of these up, they equal to 180. So right here is your final answer. Now, we move on. We add triangles and their characteristics. A triangle can be classified by its angles. The angles in an acute triangle are all less than 90 degrees. One angle in a right triangle is 90 degrees, and one angle in an obtuse triangle is greater than 90 degrees. A triangle can be classified by its sides. The sides of a scalene triangle are all different lengths. Two sides of an isosceles triangle are equal length. The angles opposite the equal sides will be equal. All three sides of an equilateral triangle are the same length. The angles will be 60 degrees. Now, let me underline the name of these triangles. It's scalene triangle, then we have isosceles triangle, and we have equilateral triangle. Those are the names of the triangles for the sides. And then for the angles, we have acute triangle, we have right triangle, and we also have obtuse triangle. Okay, so now we go down here and we have the classification by angles. Acute triangle, all angles are acute. Right triangle, one angle measures 90 degrees. Obtuse triangle, one angle is obtuse. And we already had the classifications of these different type of triangles: isosceles, equilateral, and scalene. Now it says classify the triangles. Now we have A. We notice these two sides are the same. This is an isosceles right triangle because we also have a 90-degree angle. The other two angles must be 45 degrees. And the reason why we could come to that conclusion is because the opposite angles will be the same. So if this is 90, we know 90 is left, so that had to be divided by 2 because these two angles must be the same. So that is why this statement is true. Now we have B. You notice all of these angles are different, and then since all of the angles are different, that means all of the sides are different. So this is an acute scalene triangle because all of the angles are less than 90 degrees as well. Now we come here, we have two sides that are 40, two angles that are 40. So we know this is an obtuse triangle because this angle would be greater than 90 degrees.